Okay, welcome back. Let's take a look at the second part of writing a structural formula or a displayed formula when you are given a name. This time we're going to be focusing on alkenes, right? The first compound we're looking at is 2-methyl pent 1-ene. Okay, so what we have here, like we're doing with alkanes, we start from the end of the name, working our way backwards. So the "ene" tells us that there's a double bond in the structure, and that double bond is on the first carbon, and the chain has got 5 carbon atoms, and on the second carbon we've got a methyl group. So using this here, I'll first of all start by putting together the backbone, which is the parent chain of this here. And on carbon number 1, which is this one here, this is my first carbon, the one right here, so I'm not considering that one. This is my first carbon, so that's the carbon that owns the double bond. So the first carbon you get to, that is of the two carbons that are sharing the double bond. If I'm counting from this side this way, if I get to this carbon first, that's the carbon that owns the double bond, but we know that we have to count from the side that gives the double bond the lowest number, right? So looking at this here, I've got my principal chain, and on the second carbon, which is this one here, I've got a methyl group, which is CH3, and I think that's it. And I've put in my double bond. I just need to complete the bonding capacity of each hydrogen in there, right? These ones can be a bit tricky. Why? Because there's this double bond. Most students end up just adding an extra hydrogen, which is why when we started the video on writing the formula for alkanes, I explained that if there's a double bond usually at the start of the chain, you don't get 3 hydrogens around this carbon atom here, so we only have 2. As a result, you need to, the other way is not to bother with those rules. Just make sure every carbon has 4 bonds around it. That will make your life easy. So this carbon has got 1, 2, 3, 4, so I can't add any more hydrogen. This one has got 1, 2, 3, 4, so the bonding capacity of that is fulfilled. This one here, I need 2 more to make 4 bonds, and I need 2 more for this one to make the 4 bonds, fulfill the bonding capacity of this each and every carbon. This one, of course, it's at the end, there are no multiple bonds, it requires 3 hydrogen atoms. So that's how this formula should be written for this one here. By the way, ignore this one here. It's got nothing to do, it's just a scribble that went on there. It's not a bond or anything. Okay, let's take a look at the next one. 3-ethyl hex 3-ene. We've got a double bond on the third carbon, and the chain has got 6 carbon. The principal chain has got 6 carbon atoms. There's an ethyl group on carbon number 3 as well, where we've got the double bond. So I have my 6 carbon atoms in a chain. That's 5, that's 6. Now I need carbon number 3, which is 1, 2, 3, so the double bond is right there in the middle. And on that one, I've got an ethyl group, which is C2H5. Okay, now anything else? No, I'm just counting that, which means I counted from this end, not from that end. Now, so looking at this here, I have to complete the bonding capacity of each carbon by adding the relevant amount of hydrogen atoms. I've got 4 here. I have to be careful. This one has got 1, 2, 3, 4. So I'm not going to add a hydrogen on this one because its bonding capacity is already full, up to the maximum it can go. So this one is hydrogen, hydrogen, and hydrogen right there. So this one is completed. This is how it should look like. The other thing I need to do is just to check whether or not adding this side chain with 2 carbons does not affect the name of this compound. 1, 2, 3, 4, 5, 6. Even if I count coming this way, I still have a long chain of 6. If I count from this side this way, I can't do that. Why? Because I have to go over the double bond, so the double bond must be part of the principal chain. This cannot be the principal chain. Even if it had more carbon atoms in the chain, it would not work. Why? Because it doesn't include the double bond. The rule is the double bond must be part of the principal chain. So yep, that's how we name this one. Not name, that's how we draw the structure of this one. I'm used to naming. I'm talking about naming where I'm supposed to be saying drawing. This one here is 2-dimethyl butene. So we've got a double bond on carbon number 2, which belongs to a compound with 4 carbon atoms, because but is the prefix for 4, and we've got 2 methyl groups that are sitting on carbon number 2 as well. So let's take a look at what we have here. If I've got carbon, 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 how many? 4. Yep, that's 4, and this is my carbon number 2. We have a problem with this name here. This is another one I've put in deliberately as well, because if you look at what we have here, we've got 2. It says dimethyl. Okay, I've got 2 methyl groups. Where do they go? If it says 2-dimethyl, let me try to put the dimethyl groups on the same carbon, which is carbon number 2. If you look at this carbon number 2, it now has how many? 1, 2, 3, 4, 5 bonds. I can't work it out that way. I would be having a serious problem if I was to reproduce this compound, or maybe I wanted to create it in the lab and see how it looks like and study it and look at its chemical and physical properties, or for whatever reason. Right, so this is another name which was wrongly written. Okay, it won't work because I've got 2 methyl groups that I haven't been told where they go. I know one will be on carbon 2, but where does the other one go? They can't both be on carbon 2. So probably, just out of interest, this is a wrong name, but let's just modify it so that it works. So I could have written this as 2, 3. That's the only possible option I can see working here, where I would have a CH3 here and a CH3 there. If I want to maintain a 4 chain and to have this double bond on the second carbon, if I put a CH3 at the end there, my principal chain will no longer be a 4 carbon chain. It will be like a 5 or whatever. It will end up a 5. So that's why I can't put a methyl group here or there. The only option is to put them on this carbon and that carbon, and that's just about it. So to fix this formula, this name, so that we can have a workable formula, this must be just a 2,3-dimethyl butene. So I add the remaining hydrogen atoms. These carbons already have got their bonding capacities fulfilled, because this one has got 1, 2, 3, 4. This one has got 1, 2, 3, 4. So this works perfectly well when it's like that. There's another example for making sure that when you're writing the name, you need to repeat any numbers to show side chains that are being repeated and state their positions. Even if the side chains are sitting on the same carbon, you have to repeat the number. That's why we end up with 2,2-dimethyl something, 3,3-dimethyl, exactly like that. So we need to be able to know where each component goes. Okay, let's clear up the space. We've got 2,3-dimethyl hept-1-ene. 2,3-dimethyl hept-1-ene. We've got a double bond, and on the first carbon of this 7-chain backbone of the molecule, we've got 2 methyl groups that are sitting on carbon 2 and carbon 3. So what do? We write our 7 carbon atoms, 1, 2, 3, 4, 5, 6, 7. And on carbon 2 and 3, I'll put a CH3. And on carbon 1, I've got a double bond. I'm counting from this side, as you can see, by my choice of having this as carbon 2 and carbon 3. And the last thing is to just complete the rest of the molecule by adding the relevant hydrogen atoms where they should be, just like that. When I move, you move, just like that. 1, 2, 3, 4. Right, this one here doesn't need any more hydrogen atoms. This one will need 1. Okay, so you need to just double check, go over your molecule again to make sure that everything is in place, everything is added, all the T's and dots and crosses are in place. Okay, now let's move on to the next one, which is 2-bromo-3,4-dimethyl-oct-3-ene. Let's clear this. What do we have? We have a double bond on carbon number 3 of an 8-chain principal parent chain, and we've got 2 methyl groups on carbon 3 and 4 because it says dimethyl, and we've got a bromo group on carbon number 2. So I have to write the 8 carbon atoms in the chain, just like 1, 2, 3, 4, 5, 6, 7, 8. I've got the 8 carbon atoms, and on carbon number 3, which is this one, I'll put a double bond, and on carbon number 3 as well, I will have a methyl group, which is CH3, and carbon number 4, I need another methyl group, and on carbon number 2, I've got a bromo function, side chain. Then all I have to do is to complete the rest of the chain by adding the relevant hydrogen atoms. There's a mistake here because we don't need a hydrogen right there. These are small things. I call them piranhas because they eat into your marks quite easily. So let's get rid of this. We don't need the hydrogen atoms there because the bonding capacity of this carbon has been fulfilled. And this one as well, we don't need hydrogen. We just need to add hydrogen to this one, and to that one, and to that one, and this one, and this one. Just checking, I could say 1, 2, 3, 4, 5, 6, 7. So this methyl group I've added on here will not affect the principal chain. This one is out. Why? Because if I count and go up this way to end up here, I would have left the double bond out of the principal chain, which means that won't be valid. And more so, it doesn't have more than 8 carbon atoms in the chain. So the longest one is what we've produced, and the name was properly written. Now let's look at the next one. 4-chloro-2-methyl-propyl-octene. Let's get rid of the markings on the slide and restart this. Octene in double bond on carbon number 2. We have got 8 carbons in the chain. So carbon number 2, which is 1, 2, I've got a double bond and I've got 8 carbons. So it's 4, 5, 6, 7, 8. And on carbon number 2, I've got a methyl group. And on carbon number 4, I've got a chloro. And on carbon number 4 again, I've got a propyl group, which is C3H7. Okay, now I need to complete the rest of the structure by adding the hydrogen atoms. This one needs 1 more because it has got 3 already. This one needs 2. This one requires 2. This one will require 2 as well. This one will require 3. That completes this part. Now let's just double check one thing again here, guys. I could say 1, 2, 3, 4, 5, 6, 7, 8. This is a possible chain. But the problem with going this way on the chain, coming down this way, is we're leaving the double bond out of the principal chain. So the only way we can go is this way. Right? If we check by going that way, yes, it could have worked fine as well, because this could be my principal chain 1, 2, 3, 4, 5, 6, 7, 8. That's a correct principal chain because it includes, but it doesn't violate the name, because I'm still maintaining the 8 chains, the 8 carbons in the chain, and also on the second carbon, that's where I've got my octene double bond. Now let's take a look at the last one. 1,2-dichloro-3-methyl hept 3-ene. Just clear this. So we have got a double bond on carbon 3 and 7 carbon atoms in that chain. So on the third carbon, that's where we have our double bond. 3, 4, 1, 2, 3, 4. Yep, that's fine. And 3 over there, that makes it 7. And then on carbon number 3, we have got a methyl group, which is CH3. And on carbon number 1, we've got a chloro. On carbon number 2, we've got a chloro. And we add the remaining atoms to complete this structure. This way, we know everything has been covered. We just need to double check if this checks out, but from the look of things, we've only added a CH3 there. And this CH3, if I count going this way, it adds only 1 carbon atom. But if I continue like that, I still have 2 more. So pretty much the principal chain we have here will still maintain this name as a correct name. So yeah, that's just about it on this one. The other thing is just to check the hydrogen atoms that I added to make sure they don't violate the number of bonds that each carbon must have, and that is working perfectly well as well. So that brings us to the end of this video. I shall see you when you attempt the next one.